All right, we're going to start chapter 6, which is, this is where we start doing the organic chemistry, which I know this class is organic and bio. Those first 5 chapters that we did and we started out was just kind of a review of a little bit of chemistry. But now we're going to get into the, organic. And there's only a couple of chapters. There's these 2 and there's one a little bit later about organic, and then we'll hit the biochem too. So, and again, this is a 100 level class, so it's not like we're going to do reactions and really get involved in it. I'm going to teach you the basics of how to name the compounds, what their structures look like, how to draw them, and we're not going to get overly involved in the rest of it because, again, this is a 100 level class. If you guys graduate and move on and go to another university or whatever, and you take strictly organic, then you're talking 300, 400 level classes, and then it'll get much more involved. But for this, I'm just going to teach you about, hydrocarbons, what they are, their structures, how to draw them, how to name them, and that kind of stuff. So that's what we're going to start out first. We're going to do this a little different in the sense that I'm not going to talk for 15 minutes and then give you an assignment. It's going to be much less because I want to really break up these. This chapter is just about the simple hydrocarbons. They're just made out of carbon and hydrogen, which you might think, well, big deal. There's a lot. I mean, like more than 90% of all compounds are hydrocarbons. So yeah, it's a big deal. And then, but this chapter will be the simple ones. And then next chapter, chapter 7, will be substitute groups where we start putting in oxygen and nitrogen and things like that. Okay. But again, we're going to stick with kind of simpler ones. Once I show you the simple ones, you can figure out more complex, but you need to know how to do the simple. So that's what we're going to start with. Okay. So hydrocarbons have 4 different classes. There's what they call the alkanes, there's the alkenes, the alkynes, and the aromatic. Alkanes have all single bonds. Alkenes have at least one double bond. Alkynes have a triple bond, and aromatic means they're in a ring. Okay. The alkanes, again, only single bonds, and there's included in that is the cycloalkanes. If you put cyclo in the front, that means it's a ring. So hydrocarbons are either straight chains or rings. Okay. And if they're connected all the way around in a ring, then they're called cyclo. But again, it would just be all single bonds, but just in a ring. So this would be a straight chain, and this would be a ring. Okay, alkenes, E-N-E instead of A-N-E, have at least one double bond. They might have more, but they have at least one. So you drop, whenever there's a double bond, you drop the A-N-E and you make it E-N-E. Okay. And then alkynes, that to me always sounds like you're from the South, because like instead of propene, it could be propane, propine. To me, that sounds like you're from the South. But anyway, that has at least one triple bond. So again, the ending is Y-N-E instead of E-N-E or A-N-E, and that tells you it's a triple bond. So the name tells you what's involved as far as bonds. Okay, and then we have what they call the aromatic. These are unique. There's a ring of 6. But what happens is they have alternating double and single bonds, and they rotate. A simple aromatic hydrocarbon would be what they call benzene, and we'll talk more about that too. But they're special, and again, aromatic, yes, they do usually have scents to them, and we'll talk about that as well. Okay? All right, so when you're looking at hydrocarbons, and again, a hydrocarbon is something just made out of hydrogen and carbon. If it's saturated, okay, it contains a maximum number of hydrogen. If you've probably heard saturated with like fats, there's unsaturated and saturated. Saturated are not nearly as good for you. Unsaturated is the kind you're supposed to have in your diet. And what that means is because it's unsaturated, there's a double there's some sort of multiple bond in there. And what will happen is your body can attach to that, break that double bond, attach to it, and get rid of it out of your system or use it. Whereas if you have saturated, what happens, especially when you're talking about fats, is there's no place to add anything, so they just kind of stay in your bloodstream. And if you have too many saturated fats, it builds up in your bloodstream, and people have, heart attacks. They have arteriosclerosis, it's called. Okay, the saturated just means that it's all single bonds. There's no place to add anything. Okay, and this is the formula for saturated. Whatever N is, let's say it's C2, then over here we'd have H6. This is the formula. And this again works for alkanes, not for cyclo, but just for the alkanes. This is how you determine how many you have. Okay. Alkenes, alkynes, and the aromatics, they're unsaturated because they have less than the maximum amount of hydrogen. If you do alkenes, it's CnH2n. There's no +2. with a alkene, it's 2n-2. Okay, so when you're looking at these, they have less than the maximum number of hydrogen. In other words, they have a double or triple bond, or multiples of those, and so things can attach to them. They go through reactions better because it's easier to break those bonds and add stuff. Whereas with these guys, they're already full, so they're not too willing to participate. Okay, here's some examples. Like here's a saturated hydrocarbon. This is ethane. You can see that each carbon, because carbon needs 4. Well, 1, 2, 3, 4, 1, 2, 3, 4, and you bond the 2 carbons together, and then you fill in the rest with hydrogen. This is an alkane. Okay, over here we have an alkene. Okay, and so because this double bond can be broken, over here when we had 2 hydrogen, we had 6. When we had 2 carbon, excuse me, we had 6 hydrogen. Over here we only have 4. And then when you get to here, okay, now you just have you have 2 less hydrogen even. Okay, so again, and an aromatic tends to formula wise look a lot like an alkyne, because you have those single double bonds. Okay, so again, when we're talking about saturated versus unsaturated, saturated has maximum amount of hydrogen, and it's just the alkanes. Alkenes, alkynes, and aromatics, those are unsaturated because you got room to add stuff. Okay, so as a result of this carbon's ability to bond, carbon is the most versatile, if you want to call, element, because it needs 4 bonds, so it can form all kinds of compounds. Okay, it can form, again, straight chains, branched, it can do rings. Like I said, it's the most versatile. That's why there's so many carbon compounds. Okay, here's straight chains. Okay, just carbon and hydrogen all around. This is a straight chain alkane. It's actually 1, 2, 3, 4, 5. There's 5 of them, and the prefix for 5 is pen, so this would be pentane. But they can also branch out. They don't have to be in a straight line like this. They can branch out, and I'll show you how to name those later. So because of this ability of carbon to do this, to form these 4 bonds, it has to have 4. You can drop off one of these and make a double bond. You can make triple bonds. They have all kinds of variations that they can do. Okay, so when we're talking about hydrocarbons, hydrocarbons tend to be nonpolar. Okay, so remember, nonpolar means they share their electrons equally, so they only have dispersion forces. They don't have dipoles. They don't, even though there is hydrogen, they don't have hydrogen bonding, so they don't have that strong intermolecular force. Okay, if they have more carbons, then because they're a bigger molecule, they tend to have higher boiling points. But in general, hydrocarbons, and again, hydrocarbon as an example is oil. Okay, hydrocarbons tend not to mix with water because water is polar and they're nonpolar. Remember, when we talked about solutions, we said likes dissolve likes. When we're talking about that, what we're talking about is their bonding type. So most of the hydrocarbons are nonpolar. An example again is oil. If you put oil and water together, they don't mix because they have different bonding types. Okay, the straight chain hydrocarbons tend to be a little stronger bonded, so they all have higher boiling points than branched ones. Okay, so again, some of their structure determines some of their properties. Okay, but again, they don't have a high boiling point like a lot of the polar and the ionic compounds, just because a nonpolar doesn't have that intermolecular forces. The only one they have is the dispersion forces, and they're not that strong. Okay, they don't have the other forces because of their nonpolar. In other words, they share their electrons equally. Okay, and they're also hydrophobic. Remember, phobic? They're afraid of water. I don't really think they're afraid of water. They just don't like it. So they tend not to be attracted to water, which, again, water is polar, hydrocarbons are nonpolar, so they're not impressed with water. They don't really like to hang out with water. Okay, we're going to have one more slide, I think, here. Okay, so when you're looking at hydrocarbons, many of them have common names, and it has nothing to do with their structure. Okay, and that's actually what your assignment today is going to be. There is a system, and I'll start going through this after this first unit, of how to name organic compounds. It's based on IUPAC. I think that's the International Unit. I don't remember the P something chemists, but anyway, they came up with a system to name all organic compounds, and we're going to go through that. We'll go through the simpler part of it, but I'll show you how to determine the name of every organic compound. We can do the branched ones, we can do the ones with substitute groups, we can do it all. And it's not that hard, it's just we need to do it in a, slowly, and then I think you'll get them all, okay? But when you have a pharmaceutical company that makes up an organic compound, a drug, they get to name it. So they usually have a generic name and then there's a brand name, okay? Like a simple one is aspirin. Aspirin's name is acetylsalicylic acid, okay? Nobody calls it that. They all call it aspirin. And the guy that came up with it, his name was Bayer, Dr. Bayer. And Bayer was the first aspirin, which is really funny when you look at this. Bayer, he's German. And in the World War II, part of the treaty was they had to share their patent for aspirin. That was part of it because it was such a great pain reliever. And they, it was like, okay, let's just throw that in there. Kind of weird if you think about it, that aspirin was included in a war treaty, but it was. All right, when you're naming them, there's going to be 3 parts. There's going to be a prefix that tells you what it is, how many there is. Like I said, pentane, pent would tell you 5. The ANE would tell me single bonds, and then an ending, So I'll teach you how to do all this later, but right now we're just going to start with the beginning part. So I'm going to quit here and I'll give you an assignment and we'll start working on naming organic compounds.